1.1 part that you need to know. Okay, just very fast, we go for here. Okay, what is chemical bond? Force of attraction that hold the atom together in a new species. Okay, so this normally we look at the valence electron. And then you must know what is Lewis symbol or Lewis dot symbol. So this depends on the group of the element. If we can identify the group of the element, we can assign the dot easily. So for example, lithium group 1, 1 dot. Here group 2 NS2, 2 dot. Group 13, 3 dot. Until group 18, 8 dot. Okay. Then, okay, you have to identify the group, period, or block of the element according to the valence electron. For example, this one, we have to look at the 3s1. This one, we have to check for the 4s2. This one, we have to identify 3s2, 3p4. So this is group 1, group 2, group 16. Because p block need to add 10. So this one, okay, group 15. This one, group 13. I think should be no problem for you all to identify the block and period. Because period, we check for the principal quantum number. Highest principal quantum, the highest one is the period. And then this is block P. So in this case, be careful, is 4s2, 4p6. This one is 3s2, 3p6. This one is 4s2, 4p5, group 17. Okay, just a short review. Okay, and then what is octet rules? 8 electrons around each to achieve normal gas electronic configuration. But for hydrogen, just triplet. And then we have to know how to achieve the octet rule. First, by transfer electron. Second, by sharing electron. Transfer electron is ionic bond. Sharing of electron is covalent bond. So there are 3 types of stability: noble gas, pseudo-noble gas, half-field orbital. So stability, first one, noble gas based on NS2 and P6. Pseudo-noble gas, NS2 and P6 ND10 or NS2 and P6 ND10 and F14. Half-field ND5. Okay, after that, okay, ionic bond. You must know the properties of ionic bond. Soluble in water, molten ionic, contact electric, high melting point, high boiling point, solid at room temperature. So when you form, right, okay, this one will form the cation, transfer electron to chlorine. So chlorine will become the anion. So after transfer, it becomes sodium cation. After it accept an electron, become chlorine anion, negative charge. Remember the charge. And then don't forget the 8 dot for the cation. Oh, sorry, anion. 8 dot for the anion, 8 dot for the anion, 8 dot for the anion. Must show the transformation of the electron for ionic bond. Okay. Next, if covalent bond sharing 1 or more pair. So there is no arrow, just show the sharing, okay, and then form a bonding. So here we call it as bonding pair. The rest over here, right, we call it as lone pair. So we must compare the strength of the single bond, double bond, and triple bond, and then the length of the single bond, double bond, and triple bond as well. So the strongest one is triple bond. Okay, the longest one is single bond. Maksudnya paling kuat triple bond, paling panjang single bond. Okay, then, okay, you must know what is formative bond. Formative bond is formed when one pair of provide 2 electron. Dia totally share sendiri je. Okay, dia share dua biji untuk membentukkan ikatan to form the bonding. Another one must have coordinate, have empty orbital to accept 2 electron. So lone pair, donor, empty orbital, acceptor. So these are the example: hydroxonium ion, ammonia, boron, chloride. Remember, must show, okay, these, okay, lone pair share to this electron, so form the coordinate bond, coordinate bond, must show. Oxygen ni membagi 2 electron bagi hydrogen. Okay, then next is about drawing restructure. Identify the central atom, count the valence electron, and then draw the bonding. This is the step. Okay. After that, we need to know what is formal charge. Using the total number of valence electron minus the total number of lone pair plus half times total number of bonding pair. Okay, based on the formal charge, right, we try to get the lowest one. Because if there are two Lewis structure, we will choose the lowest formal charge as the more stable structure. Okay, if there are three, okay, in this case, okay, besides we choose the lowest formal charge, we have to check, okay, this is negative, okay, this one and -1 for nitrogen, -1 for sulfur. So -1 should go to the located on the more electronegative atom. So it's nitrogen because nitrogen is more electronegative than sulfur. So this is about function of formal charge. Next is exception to octet rules, incomplete octet, expanded octet, or number octet. So I taught you all before, right? Incomplete less than 8 valence electron. What, for example, Sn, beryllium, boron, aluminium, because electron deficiency species. Okay. And then expanded more than 8. Okay, non-metal atom of the third period onwards and due to the existence of MTD orbital. Odd number of electron. So for example, group 15, nitrogen, and then group 17, chlorine. Okay, next we need to know, after that, okay, we need to know how to draw the resonance structure. Resonance structure normally happen for the structure that have single double bond. This and this, both are the same. Both are correct. Okay, that's why for here, right, two or more possible Lewis structure can be written for certain molecule, but cannot neither one could accurate. It means both correct. So dotted line show the delocalized of electron. Another name for resonance. 2 is related with molecular shape and polarity. As I told you all before, right, we must know how to draw the Lewis structure, then only can proceed for molecular geometry and polarity. Molecular geometry and molecular shape is the same. So in this part, we must know what is valence shell electron pair repulsion theory. Draw the basic molecular shape. The basic means linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Okay, if there is no lone pair, okay, the shape still the same. If there is lone pair, right, the shape and bond angle different already. After we successfully draw the molecular geometry, we can proceed, okay, to show the bond dipole and predict the dipole moment. Then only can deduce the polarity. So first, okay, molecular geometry is a 3D arrangement of atom in a molecule, affect physical and chemical properties. It's predicted by using the VSEPR model. What is EPR? VSEPR. It's an electron pair around the central atom will repel one another and arrange themselves as far apart as possible from each other. Why we need to arrange? Because we want to minimize the electron pair repulsion around the central atom. There are two types of electron pair around the central atom, bonding pair or lone pair. Okay, so this theory can predict the molecular shape, represent the lowest energy configuration of polyatomic ion and molecule. Okay, so always remember, highlight, double, triple bond counted as one bonding pair. Have the same effect on bond angle as a single bond. So there are three types of repulsion: bonding pair, lone pair, bonding pair, lone pair, lone pair. Okay, among these, lone pair is the strongest one. So the weakest one is the bonding pair. Okay, so this one I got you all before. So first you must identify the class of molecule. A is referred to central atom, B is referred to bonding pair, and the E is referred to lone pair. So next, total number of bonding electron and lone pair, right? We call it as electron pair arrangement. Electron pairs. So the electron pair arrangement is the name for the structure. If 2 linear, 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. Okay, and then the molecular shape have to check for the lone pair as well. So this one, linear. Okay, this one, trigonal planar as the basic shape. If there is one lone pair, we call it as V shape. The electron pair arrangement still trigonal planar, the shape is V shape. Initially is 120 degree. When there is a lone pair, less than 8. So type of repulsion, this one just bonding. This one bonding lone, bonding. Okay, if 4 tetrahedral, if there is 1, the molecular shape will change to trigonal pyramidal. But remember, electron pair arrangement still the same. And then for this one, V shape. Okay, so type of repulsion you can refer to here, bonding, 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 lone pair bonding, lone pair, lone pair, lone pair bonding, bonding, bonding. Okay, if there are 5, it's trigonal bipyramidal. 1 lone pair becomes seesaw. Okay, if 2 lone pair, AB3E2, T shape. AB2E3, linear. This is linear shape, T shape. When we assign the shape, right, we check for the molecular shape. This is like T, this is linear. Just now, this is trigonal bipyramidal, and this one square planar, seesaw, jongkang jongkek, seesaw, ataupun distorted tetrahedron. If there are 6 octahedral, 1 lone pair, square pyramidal, 2 lone pair, square planar. As I said before, right, the 5 basic geometry plus square planar with the same terminal atom confirm the dipole moment can cancel off each other because they are symmetry. So mu equal mu equal to 0. Sorry, mu equal to 0. So non-polar. That's why this is the step in drawing molecular shape. So you just follow everything. Start with Lie structure, assign. Okay. Check for this one. Effect of lone pair on molecular geometry. Lone pair of electrons are closer to the nucleus compared to bonding pair. Lone pair of electrons exert stronger repulsion on one another. That's why when there is a lone pair, right? So the lone pair will push the bond. That's why the bond angle will be smaller than the original one. So there's effect on the bond angle. Okay, check. Okay, among these 4, we compare. Initial is 109.5 for the tetrahedral CH4. But NH3 1 lone pair become 107.3. If there are 2 lone pair become 104.5. This is water. So when we answer the question, right, we can answer in table like this. First, you tell me, draw the Lie structure, and then tell me there are 4 electron pair arrangement, or is tetrahedral. Okay, 4 bonding pair. This is AB4, AB3E1, AB2E2. So type of repulsion for each other, and then the molecular shape of each of them, and then the bond angle. So you must explain this one. After that, you must explain about this one. Strength of the electron pair is like this. Okay. Okay. Effect of electronegativity towards bond angle. Just now is about lone pair. Now we talk about electronegativity. Higher electronegativity, stronger the attraction, the larger the bond angle. So for example, for this case, both of them AB2E2. 2 bonding pair, 2 lone pair. Why the bond angle for this one is smaller compared to this one? Okay, why? Because O is more electronegative than sulfur. So the bonding electron in OH are closer. So this one closer. Okay, that's why the bond angle of OH is larger than SH. Okay. Just now we talk about lone pair. Now we talk about electronegativity. FON. Fluorine is the most electronegative atom over the whole periodic table, followed by O and then N. Okay, so O is more electronegative. So OH bond are closer to O compared to the bonding pair in the SH. So repulsion between the OH is stronger, cause the bond larger. Take note, huh? So next compare. Okay, next about polarity. Okay, before I proceed for polarity, any question do you want to ask? Haikal tak ada lagi. Yeah. Today just a short review, so that easier for you to complete the tutorial again, do the revision for tutorial. Okay, we continue. Polarity. First of all, we must know what is polar bond, polar molecule, different electronegativity, asymmetry, and then positive and negative dipole can be distinguished. This is the key point to identify whether it is polar bond or polar molecule. Berbeza electronegativity means the positive negative berbeza. Electron letak pembahagian elektron pun berbeza. Next is about symmetry ke tak? Okay, so I want to ask you some question. I random ask. Just like I got mentioned, there are 6 molecular shape. It's symmetrical if the central atom is the same. So please tell me the 6. Okay, testing Badru bagi saya tahu satu. Badru, ada cakap tadi ada 6 yang memang simetri dengan syarat dia terminal atom sama. Ada 6. Badru sila nyatakan satu. Ahmad Badru, are you here? Divya, give me one.
Madam, the symmetry for molecule shape.
Yeah. That's why I got mentioned 6.
Okay, Trigonal Planar.
Okay, stop. Stop. I random pick. Okay, thank you, Zul. Zul just now give Trigonal Planar. Badru, please give me one. Divya, give me another one.
Wait. Mana buku
Mana buku? Tadi ada terang. Jangan kena cari buku lagi. Okay. Divya, are you here? Okay, lagi satu I pinggir. Imran.
Tetrahedral.
Okay, bagus tetrahedral. Divya, where are you? Trigonal bipyramidal, yes. Lagi 3. Tengok Ana panggil siapa. Aina? One Aina, Sophia?
Octahedral, madam.
Okay, bagus. Octahedral, betul?
Linear
Badru?
boleh, linear.
Apa?
Linear boleh? Linear.
Betul lah. Linear tu paling ringkas. Betul? Lagi satu. Tania betul. Linear betul. Trigonal planar betul. Tetrahedral, trigonal bipyramidal, octahedral betul. Lagi satu yang ada lone pair dia akan jadi simetri.
Square planar tu, madam.
Pandainya Aisyah. Betul. Square planar. Okay. Terima kasih semua. Inilah 6 molecular shape yang memang simetri. Dengan syarat lone pair, terminal sama. Hujung dia, setiap terminal atom sama. Dia memang simetri. Dipole moment boleh cancel off each other. Mu equal to 0. Non-polar. Yang lain tak payah fikir. Kalau dia dapat bentuk yang lain, dia memang tak dapat cancel. Jadi dipole moment tak boleh cancel, maksudnya mu not equal to 0. Polar. Senang je polarity. Tu je prinsip dia. So that's why you pergi check semula semua benda ni. Okay, polar, non-polar. Non-polar, same or similar electronegativity, share equally. Okay, nampak? Corinne, bromine?
Nampak, madam, nampak.
Okay, good.
Nampak.
So, tengok ni. Share equally. Mesti non-polar. Yang ini, berbeza. Partially positive, partially negative ke satu arah. Tak boleh cancel. Mu not equal to 0. Polar. Okay, not share equally. Yang ini, trigonal planar, linear, trigonal bipyramidal, semua hujung sama. Ini symmetrical shape. So, mesti sama dengan kosong. Mu sama dengan kosong. So, non-polar. Yang ini, ni tambah tak? Dia octahedral. Octahedral sepatutnya simetri. Tapi hujung ni tengok, ni sama ke tak? Hujung berbeza. So, tak boleh cancel. Mu not equal to 0 polar. Ni tetrahedral juga. Tapi terminal berbeza. So, polar molecule. So, this one all considered as asymmetrical shape. Because due to the terminal atom not identical. Okay, kerana terminal tak sama. Walaupun dia tetrahedral, walaupun dia octahedral, tapi hujung berbeza. Jadi dia asymmetrical. Not symmetry. Mu not equal to 0 polar. Yang ini. Nah, ni tadi saya cakap square planar. Symmetry. Okay, non-polar. Yang lain tak payah tengok. Ni V shape. Ini trigonal bipyramidal. Trigonal square pyramidal. This is square pyramidal. This one is trigonal pyramidal. Ni semua tak simetri. Dipole moment ke atas, dipole moment ke atas. Yang hijau ni lah dipole moment ke atas. Resultant dipole moment. Yang hijau ni resultant dipole moment. Semua mu not equal to 0 polar. Ni pun sama. Semua pun polar. Kecuali ni. Kecuali ni. Mengapa? Ni linear. Kanan, kiri cancel. Ni linear. That's why dia non-polar. Ni tak semua tak dapat cancel. Okay, so ni contoh dah bagi semua dah. So contoh ni semua contoh. Setiap contoh pergi tengok sekali lagi. Okay, so semasa kita, when we want to explain about polarity essay question, short essay question. Okay, I show you all before. You must write down. Must. Kalau ingat, semasa kat cafe hari tu, I mesti tulis partially negative. Partially positive. Wajib tulis. Partially negative. Partially negative. Kemudian tunjuk typo moment dari positif ke negatif. Positif ke negatif. Positif ke negatif. Okay, lepas you buat list structure ni, buat macam ni, you kena beritahu. Ini point number 1. Geometry prediction tetrahedral. So class dia AB3E1. Kemudian bentuk dia trigonal pyramidal. Ini dari molecular geometry. So first beritahu more electronegative. Jadi bond dia memang polar. Lepas tu, ni bond polar masuk ke NF polar. Dia bukan cakap molekul. N positif. F partially negative. That's why here is each bond are polar. Why each of them are polar? Because F is more electronegative than nitrogen. Second point, not symmetry. So, bond typo of NF does not cancel. Mu not equal to 0. So, NF is a polar molecule. So, this is the way to answer the essay question. Remember, show it. So, explain. Explain the bond. And then explain the symmetrical or not symmetrical. So, can cancel or not. What happened to the mu? Means the dipole moment. And then conclusion. Polar molecule or not polar molecule. Tadi cakap pasal bond. Ini cakap pasal molecule. Clear? Clear? Okay. So that's all for polarity. Any question do you want to ask before I proceed for the orbital overlap and hybridization? Ada soalan nak tanya? Haikal.
Okay, madam.
Ya.
Kalau untuk yang tadi tu kan yang kan kalau hydrogen, kalau yang untuk polarity hydrogen kan dia akan pergi ke center atom kan. Hydrogen tu dia punya polarity positif.
You kena tengok hydrogen banding dengan apa. Hydrogen dia biasanya positif.
So kalau expression dia kita cakap apa hydrogen is more electropositive ke atau kita cakap contohnya fluorine more electronegativity than hydrogen?
Kita biasa cakap more electronegativity. Tak salah, dua-dua pun betul. Biasa kita akan cakap macam ni, F is more electronegative than hydrogen. Kita biasa cakap negatif.
Okay, madam.
Electronegative Electronegative.
Okay. Electronegative.
Lagi? Okay. Kalau tak, kita sambung sikit untuk part ini. Today more focus on lecture notes. Kita brief, Madam brief semula lecture notes 4.1, 4.2, 4.3 sekali lagi dengan you. Sebenarnya Madam dah habis ajar. Tapi ajar sekali lagi supaya you tanya ada apa nak tanya. Okay. Okay. So now we look at here. Okay. Nama dia pun orbital overlap and hybridization. Overlap means bertindih. Kita akan mengkaji macam mana orbital tu bertindih. So there are 3 parts. First, formation of sigma and pi bond, and then formation of the hybrid orbital, and draw orbital overlap and label sigma and pi. Okay, so 2 common approach to chemical bonding. One is valence bond theory, another one is molecular orbital theory. Ini hanya basic je, tak berapa penting, tapi kita tengoklah apa valence bond theory cakap pasal. A covalent bond is formed by pairing of 2 electrons with opposite spin in a region of overlap of atomic orbital between 2 atoms. Means A share satu elektron, B share satu elektron, satu kat atas, satu kat bawah, bentuk satu ikatan. This overlap region has a high electron charge density. Tempat yang men-sharekan, mengkongsikan elektron, banyak elektron lah. So ada dua jenis, sigma and pi. Formation of sigma is end-to-end overlap, high electron density along the axis, free rotation, single bond are sigma bond. All the single bond is sigma bond. So there are three types of sigma bond can form between S and S orbital overlap because hydrogen one, this hydrogen one, they share so opposite spin. This is the region. Okay, overlap of two S orbital. Second one is S with P orbital. Third one is P with P orbital. Okay, formation of pi bond side to side overlap occur in molecule with multiple bond. Has two regions of electron density, one above, one below the sigma bond. One pi bond holds two electrons that move through both regions. So kita tengok contoh, apa maksud dia kat sini? One pi bond, dua-dua ini baru jadi satu pi ya. So side to side overlap. Dari hujung ke hujung macam ni, side, tepi ke tepi overlap. Okay, and one above, one below. Satu ke atas pi, satu ke bawah, baru bentuk satu pi. And then hold two electron through both region. Both region, satu atas, satu bawah. Here is sigma bond ah. Bahagian sini sigma. Bahagian sini pi. Okay. So this is one sigma, one pi. This one sigma, two pi. You check the pi bond must be parallel. Nampak satu kotak, satu palang. This one sigma, two pi as well. Okay, hybridization. Hybridization is the mixing of two or more orbital in an atom to form a new set of hybrid orbital. The spatial orientation of the new orbital is called multiple bond and are consistent. Okay. Sebelum I proceed, I kena buka satu benda bagi you tengok semula summary dia. As I said before, right? Type of hybridization, there are 1, 2, 3, 4, 5. If linear, SP. Trigonal planar, SP2. Tetrahedral, SP3. Trigonal bipyramidal, SP3D. Octahedral, SP3D2. This one according to the basic shape. Okay, ah. So dengan konsep ni kita masuk sini senang sikit. So this is what I say, linear. SP, bond angle 180. 2 electron pair. If 3 electron pair, trigonal planar, SP2. S with 2p. So form 3 SP3, SP2 hybrid. SP3 like this. Be careful when you draw the SP3 not palang you see, slanted down Okay, trigonal planar 5. Bond angle with these two octahedral. Okay, so again, draw this structure, predict the molecular geometry, hybridization center. Okay, start to draw the orbital diagram for the central and the terminal and explain. Draw the overlapping. So I think step 1, 2, 3, no problem. Okay, part 4. If part 4 you can understand clearly, no problem for the part 5. Okay, I rasa sini semua boleh faham. Restructure molecular geometry, predict the hybridization. 4, tetrahedral, sp3. Okay, now check for here. You base on this diagram, how many bonding pair you need? Adam, berapa bonding pair? 4. Okay. So this is the ground state for carbon. Carbon only can allocate 2 electron only. Not enough. Tadi you beritahu saya 4. But here only 2. That's why one of the electron will excited over here. Now can form the 4 bonding pair. That's why it can form only 2 sigma bond if with this ground state orbital diagram with hydrogen in its ground state. 1 electron from the 2s over here has to be excited to this unoccupied 2p orbital. So in the excited state, there are 4 unpaired electrons in carbon atom. So now it can form 4 bonding pair with 4 hydrogen atom. So the 2s orbital and the 2p orbital mix. Now s and p mix together form 4 equivalent sp3 hybrid orbital. So 1, 2, 3, 4. That's why dia boleh bentuk 4 bonding pair dengan hydrogen. Always must remember the orbital diagram must tally with the molecular geometry. Okay, so your drawing is like this. Label the central atom, terminal atom, a pair of electron, label sigma, and then the orbital for hydrogen 1s. The orbital for the carbon is sp3. Okay, also remember to draw the orbital diagram for ground state. Okay, so this is the explanation for the hybridization diagram. Okay, next, for this one, I think should be no problem for this slide. So we check 1 lone pair, 2, 3 bonding pair. So this is the orbital diagram for nitrogen. 1 lone pair, 3 bonding pair. So in this case, there is no excited state. Bukan semua pun ada excited state ya. Sekiranya okey, cukup tak payah. Ini untuk lone pair. Kat 3 ini memerlukan 3 bonding pair. So over here. To form the bonding with hydrogen. So ni penerangan dia lah. So sp3. Okay. Ammonia. Okay, water you check. 2 lone pair, 2 bonding pair. So this is the ground state for oxygen. 2 lone pair, 2 bonding pair. So is enough. There is no excited state. So straight away hybrid sp3. sp3. Okay, the hydrogen one. Okay, lukisan ni salah. Okay, betul kan sekarang? Lukisan ni salah. You sepatutnya kena buat macam ni. Hydrogen you kena kat sini. Bukan kat sini. Dia kena macam bentuk ni. Dia kena bentuk macam ni. Lone pair, bonding pair, bonding pair.
Ikut molecular shape.
Yes, according to the molecular shape. Yes, please do the correction over here. Semua orang betulkan sekarang keluarkan lecture notes. When I explain using your lecture notes, right, you also have to take out your lecture notes. So this is the lone sigma bond over here. Here just lone pair. Form the overlapping over here and then label sigma. This is your hydrogen 1s. Okay, kat sini hanya dia je lone pair. Ni tak ada. Semua ni tak ada. Hanya tinggal je lone pair kat sini. So must draw like this. V shape. Okay ya. Okay, sampai sini boleh faham? Before I proceed for the next. Okay. Next is trigonal planar. 3 bonding. So you check. In this case, only can form 1 bonding. Not enough. That's why excited state. So one of the electron from 2s excited over here. Okay. So 1 unpaired electron only and can form only 1 sigma bond with other. Therefore, one of the electron from the 2s is promoted or excited, perkataan yang sama, to the unoccupied 2p orbital. So now it's formed, mixed together, three of them mixed together to form the sp2 hybrid orbital. And then the remain 2p empty orbital must write down as well. Okay, so form with 2p fluorine. That's why 2p fluorine like this. Okay, this K is related with pi bond, and there are two central atoms. Both of them are sp2. This one is sp2. This one is sp2 as well. Okay, I think should be no problem, no problem, no problem. Can. Okay, 3 bonding pair, sp2. Now we check for the the orbital diagram. So you check. This is a ground state. I want to find 1 sigma, 2 sigma, 3 sigma, and 1 pi bond. I memerlukan 4. 3 sigma, 1 pi. Cukup ke tak? Tak cukup. That's why I need to excite it. Once I excited, these three will mix together, become sp2. Another one is 2p unhybridized orbital or 2p pure orbital. Faham? Kita kena memastikan ada satu kekosongan untuk pi juga, tapi pi tak termasuk dalam hybridization. That's why it's unhybridized orbital. Okay, so hydrogen remain hydrogen lah. So this is the diagram. The blue color one is the trigonal planar. And then the green color is the pi bond. But this screen is not really parallel. Make sure it's parallel. Pastikan betul-betul selari. Pi bond mesti betul-betul selari ya. That overlap.
Madam,
Yep.
Madam.
saya nak tanya.
Madam yang
Tak apa, Syamiah tanya dulu. Syamiah tanya dulu.
Cakap je. Syamiha dulu.
Madam yang tadi tu kenapa dia bukan SP3
Oh, yang ni ya?
Ha.
Tadi, madam dah kata. Okay, you tengok apa bentuk dia. 1 sigma, 2 sigma, 3 sigma kan? 3 bonding pair kan? 3 bonding pair. 3 bonding pair. Trigonal planar kan? sp2.
Oh.
Tetap. Ini memang tetap. You have to check for the lone pair and bonding pair. Sum up is equal to 2 linear. Okay? 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. This is the number of electron pair. The number of electron pair is lone pair plus bonding pair. Okay, so you go back to this. Okay, you check for this one. 1 sigma, 2 sigma, 3 sigma. 3 sigma 1, 3 bonding pair, trigonal planar. Trigonal planar 3 kan? That's why sp2. Okay?
Okay, madam.
Zu nak tanya apa?
Madam, saya nak tanya, adakah kalau kita ada double bond tu adalah pi? Betul ke?
Yes, confirm. Confirm. Kalau ada double bond tu pi. So I go back to here. Kalau you tanya soalan ni, maksudnya tadi kat sini you tak clear sangat. Oh, dia bukan kat sini. Dia kat 4.1 kalau tak silap. Okay, tengok sini. Kalau single bond, sigma. Kalau double bond, 1 sigma, 1 pi. Jadi untuk ni, untuk carbon ni berapa sigma, berapa pi? Zu?
2 sigma, 2 pi.
Yes, 2 sigma, 2 pi.
2 pi.
For this case,
Wait.
nitrogen?
2 sigma, 1 pi.
Again?
2 sigma, 1 pi.
Wrong. 1 sigma, 2 pi. 1 sigma, 2 pi. Always remember, setiap kali ikatan semua ni hanya 1 sigma je. Yang lain memang pi. 1 sigma, 2 pi. 1 sigma, 2 pi. Okay, that's why semasa lukis, one sigma, 2 pi. Nitrogen triple bond. 1 sigma, 2 pi. Yang ni kotak-kotak, ni dengan palang-palang. Clear? Okay, this one double bond, right? O double bond. So 1 sigma, 1 pi.
Pi.
Okay, this one triple bond. 1 sigma,
1 sigma
2 pi.
2 pi.
Pi. Get it? Clear?
Get it. Okay, clear.
Okay, yeah. Okay, so when you draw this, right, you must allocate one orbiter for the pi as well. So that's why in this case, I need 3 for sigma, 1 for pi. Okay, that's why 1, 2, 3 hybrid become sp2 because 3 bonding. Another one is the 2p unhybridized orbiter for pi bond. Jot down. This 1, 2, 3 trigonal planar sp2. For this one is for the pi unhybridized orbiter. Okay, so this is the diagram, hybridization diagram for C2H4. Okay, sp2, sp2, sp2 form the sigma bond with hydrogen, this one C1, C2, and then this one C2 from the sigma bond from the hydrogen over here. Here is the pi bond. Up and down electron overlap 2 lobes up and down to form 1 sigma bond. Mesti tunjuk overlap atas, overlap bawah membentuk 1 pi bond.
Okay.
Okay, okay, this is linear, simple. AP2, so 2 electron pair. So ground state macam ni tak cukup, kena excited untuk bentuk dengan 2. So SP, this is 2p empty orbiter. Dia bentuk dengan siapa? Dengan fluorine, 2p. Kalau fluorine, p orbiter. Kalau hydrogen, spherical. Okay, ni tengok. Zu, berapa sigma, berapa pi?
1 sigma 2 pi.
1 sigma 2 pi. Here another sigma. That's why you need 2 sigma for this carbon.
Okay.
Okay. Okay, 1 sigma 2 sigma linear lah. Okay, so SP. Syameha 1 sigma 2 sigma 2 bonding pair. Linear SP2 SP . Ni SP kerana dia 1 single untuk sigma, 1 single sigma untuk carbon. Okay, linear.
Okay, madam.
Dan 2 pi. Jadi lukisan dia macam ni. 1 sigma dengan hidrogen, 1 sigma dengan C satu lagi. Pi hijau 1, pi hitam 1. Okay, kita patah balik tengok penerangan dia. So, Lee structure. Okay, molecular geometry, class of compound, molecular shape. Okay, and then bond angle, number of electron pair, 2. That's why SP, hybridization. So, dia kena ada berapa ikatan? Dia kena ada 2 sigma, 2 pi. So, that's why need to excited. So, 2 for bonding pair, 2 for sigma, that's why SP. Another 2 is the pure orbiter or unhybrid orbiter. So, you akan nampak, ada kadang-kala pi kita tulis pure orbiter, kadang-kala kita tulis unhybridized orbiter. Sama je. So, kalau bagi saya suka tulis pure. Senang sikit. P-U-R-E, 4 perkataan je. Unhybridized banyak perkataan. Okay. So, empty means kosong. Kalau dia kosong, you kena tulis juga 2p empty orbiter. Okay, now the ground state is for okay, the ground state is for hydrogen ground state 1s. So you explain overlapping of the carbon sp3 hybrid orbiter and the 1s orbiter hydrogen atom generate sigma bond. Another one is overlapping of both carbon sp. Okay. If you look at the lecturer's explanation, right, maybe you feel a bit complicated, but for me, I prefer like this. Listen. The first explanation. And I go for here. This one is C1, this one is C2. sp hybrid orbiter of carbon atom is overlapped with sp hybrid orbiter of C2 atom to form sigma bond. 2 kat sini. sp hybrid orbiter of carbon 1 is overlapped with the 1s orbiter of hydrogen to form sigma bond. 3. sp hybrid orbiter of carbon 2 is overlap with the 1s orbital of hydrogen atom to form sigma bond. Okay, 4. 2p orbital of carbon 1 is overlap with 2p orbital of carbon 2 to form 2 pi bond. Tu je. Faham? Explanation madam berdasarkan gambar aja. Ataupun you nak ikut macam ni pun tak kisah. Boleh je. Janji masuk tu ada. Okay.
So kalau kita explain guna gambar aja je dah cukup kan madam?
Cukup. You tengok penerangan apa yang saya cakap tadi sama tak? Okay, ni SP 1S. SP both carbon sigma. And then pi bond 2p unhybrid carbon 2p unhybrid other carbon pi bond. Sama je lah.
Okay.
Kan? Janji maksud tu ada. Okay. So this is diagram. Always remember the pi electron density is above and below plane of nuclei of the bonding. Sigma is density between. Here is the sigma. Ni sigma. Ni pi. Okay. Okay, ni 5 lah. Trigonal bipyramidal. Pasti kata 5. So, I nak 5 tapi sekarang 3 je. That's why excited. So, this is the excited state. Kemudian mix semua sp3d. Yang tinggal tu MP orbital. So, terminal just buat biasa je 3s2 3p. Lukisan seperti biasa. Pastikan label sp3, label guna color lain. Pastikan label sp3 semua ni kena label. Pastikan electron pair ada, label sigma. Central atom phosphorus, terminal atom chlorine, terminal atom 3p. Okay, untuk 3p ni label sekali je, tak payah 2 kali. Betul kan? Ni, tak payah. 3p label sekali je. Label sekali je. Dia memang satu 3p je, bukan 2. Padamkan. sp3d 5, 3p 5, chlorine 5, phosphorus 1, sigma 5, electron pair 5. Okay, so this is octahedral. Sama, octahedral I nak 6, sekarang 2 je. That's why excited. So this is the excited state, sp3d2. Okay, fluorine 2s2 2p 5. Okay, lukisan dia lah. Okay, sekali lagi 3p sekali je, ni padamkan. Okay, yang lain okay, yang lain betul. Okay, exercise tadi semua exercise. Okay, 4.3 habis. Okay, so tadi madam telah buat ulang gaji dengan 4.1, 4.2, 4.3 dengan semua. Jadi nokta pergi semak semula. 4.1, 4.2, 4.3 ada masalah tak? Dan 4.4 pastikan siap. Kita akan sambung 4.4 dan 4.5 esok. Okay, sementara tu macam you all mesti kena share I kena share juga. Tanya?
Kalau manipulation tu, kita tak tulis dia punya degree. Salah.
Molecular shift tak tulis apa?
Dia punya degree, darjah dia. 120 darjah kita tak tulis.
Kalau boleh, you tulis pun angle lah. Lebih baik tulis. Kita tak tahu markah tu macam mana. Kerana I dah kata kalau you tahu, tuliskan.
Okay.
Tuliskan. Okay, I nak share. Okay, kat sini. Semua orang nampak Google Classroom? You nampak Okay, nampak tak? I ada 3 assignment yang baru. Saya ada tulis week 10. Okay, first state of matter semua dah hantar. Tanya. Yang ni periodic table assignment semua pun dah hantar. Tanya. Okay, attendance SKL, attendance SKT. Okay, SKT hari ni lah. Ni 1 hour. SKT hari ni 1 jam. Okay, pergi klik. Oh, ada 4 orang turn in dah, Tania. Okay, this week activity, please do a summary. Okay, ni you buat je lah. Pastikan tick attend lah. Next time, madam dah ada Google Form dah. Kita terus guna Google Classroom kat sini. I buat attendance, you tick attend je. Kalau siapa tick tu, maksudnya dia sudah hadir lah. Kemudian pastikan apa yang instruction saya tulis ni, you buat je lah. Ini untuk 1 jam. Okay, yang lagi ada 2 jam, tadi ada SKL. Ikut je buat. Setiap tu tick attend. Saya check berapa orang turn in. Kalau turn in tu maksudnya you sudah hadir kelas dan siap kerja. So attendance, hasil kerja semua berdasarkan Google Classroom. Senang kerja. Faham? Okay, so madam tak payah check link dah. I hanya check Google Classroom, you turn in.